Okay, we are up to question 18. Prove that chords of equal length subtend to equal angles at the center of a circle. So what will that involve? We'll, I guess, be making some triangles with these chords and making the angles at the center. I might actually use my straight line here. Hopefully it lines up well. Might use my mouse for that one, might be a bit more accurate. So if you have a line there, not that one, and then we have a line here, line here, line here, we should hopefully be able to see that these are identical. And therefore the triangles are congruent. You should be able to say which sides are identical and therefore it should be fairly self-explanatory that the angles are therefore going to be the same as well. I'll just put down all the writing that I would put for this. So there's my script. Hopefully it's all fairly straightforward. Probably should be expected that when you've got so many things similar, you'll have the angles similar as well. All right, moving on to the next question. Points P and Q lie on a circle of radius 23.3 centimeters, so that PQ equals 21 centimeters. So I guess you can do a rough drawing of this. Okay, so I have my chord, I have my radius. I guess when you're trying to figure out the distance all the way down to the center, I'll just go a different color for a quick second. So I'm going to go from the center to the center of the chord. So we know we are unsure of what that value is going to be, but we are sure of what this value is going to be. This diagonal one here is going to be the radius. And from one side of the chord to the part in the middle, which will line up with the origin, no matter where we had drawn the chord, that is obviously going to be half of what that chord is going to be. So that's going to be 21 over 2, which is 10.5. So that means we, in our triangle, just doing it very roughly over here, you know that the diagonal is going to be the R of 23.3, and you know that the distance at the top here is going to be 10.5, half the radius, and it's going to be a right angle triangle. So you're just going to end up solving for that one using Pythagoras, and the working out will look as follows. And there we have it. I've just labelled the side OM because it goes from the origin to the middle of PQ, which I called M, as you can see from my picture. So hopefully that's fairly straightforward. Now we move on to the next question. The angles subtended by chord PQ at the center of the circle. So I'll just draw my beautiful circle. Now remembering that subtended means it will be the angle that is made by a line that comes from each of the 2 points. So if I do a line from one point and I do a line from the other, we'll be able to make it. Now a critical thing here that will make things a lot easier will be if I had, and I'll do this one green, if I had a line that just goes down the middle. So if I have a line that goes down the middle, that ends up meaning that I make right angles. And when I've made right angles, then it's going to be pretty easy to end up finding out what everything is, because each of my triangles will be OM distance, which we figured out was 20.8. So again, just very roughly my little triangle drawing. This is the little triangle on the left there. It's going to be 20.8, and it's going to be actually, to make it more precise, what we should actually do is just use the values that we have before rather than the one that we've done a little bit of rounding to. So we're going to have our little triangle is going to be 10.5, not to scale obviously, and the radius which we got told was 23.3. And we are trying to find out this angle, which will be this one over here, and once we've found that out, we can double it to get the whole angle between the two lines. So for that we'll use sine, and the working out will look as follows. And there's the working out. Just remembering that once I have figured out that angle, I will have doubled it by 2. That way it gets both parts, both triangles, because we're trying to figure out what is the angle that is made subtended by the chord, not just by half it. We only halved it just so then we could simplify our working out sum. So that is how I worked out those questions.